Your bash SSH script worked on one server, then half failed on 20. One host had a space and a value, one command in a pipeline failed silently, and your log file is a single unreadable blob called rollout.log. Now you cannot tell which host changed, which host failed, and whether running the script again will repair things or double break them. That is the problem behind the search. Bash SSH script best practices. Not fancy orchestration, just disciplined bash, predictable SSH behavior, and scripts you can rerun under pressure. SSH is often the simplest remote execution tool you have. You already trust it, log it, restrict it, and use keys for it. The trouble starts when a local bash script, a remote shell, and network failure all share one line. Best practice means separating those layers. The local script controls host loops, logging, and input preparation. SSH transports a command to one host. The remote bash block performs a small idempotent change and exits honestly. If each layer has a clear job, you get better operations and better defense, fewer mystery changes, cleaner audit trails, and failures that stop instead of spreading. There are 4 mechanics to burn in. First, put set-Eeuo, pipefail, at the top of both local and remote bash. It is not magic, but it catches many bad assumptions. Second, send remote code with a quoted heredoc. The delimiter is quoted, so your local shell doesn't expand remote variables before SSH sends the text. Third, when a local value must cross into a remote command line, quote it deliberately. In bash, printf %q produces a shell-escaped representation. Fourth, log per host. 100 hosts sharing one output stream is not evidence, it is confetti. Here is the compact pattern. The first line sets a host and a local value containing a space. The second line turns that value into a shell-safe token using printf %q. The SSH line uses your client config with $F, connects to the host, and runs remote bash reading its script from standard input. The escaped value becomes positional parameter 1 after the double dash. The heredoc delimiter is quoted. Single quote remote, single quote. That is the important part. It prevents local $signs inside the block from expanding on your laptop. The remote bash then enables strict mode and uses $1 normally. A real pattern looks like this. Create a logs directory, loop over hosts, and write 1 log per host. In practice, replace uptime with the heredoc pattern from the previous card. Maybe you are ensuring a directory exists, installing a managed config file, and reloading a service only when content changed. Each operation should be idempotent. Creating an existing directory is fine. Installing the same file again should be fine. Reloading a service after a verifying change is fine. If app2 fails, app1's log remains clean. App2's log has the evidence, and a rerun should converge the system instead of stacking damage. The most common mistake is an unquoted heredoc delimiter. Then $home, $path, or $variable may expand locally before the script ever reaches the server. The second mistake is logging everything into one file and then pretending the exit code tells the full story. The third is worshipping set-e. It has exceptions, especially around conditionals, tests, and compound commands. Check important outcomes directly. Also think about secrets. If you pass tokens, do not echo commands with xtrace. Do not tease secret material into logs, and prefer positional arguments or managed files with correct permissions over giant remote command strings. This sits in the middle of the practitioner tier. Earlier, SSH config gave us repeatable host definitions, usernames, ports, keys, jump hosts, and timeouts. Key management decided which identity the script uses. Logging and journal tell us what happened after the connection lands. Later, automation tools and systemd timers can run these scripts on a schedule, but the same discipline applies. Clean input, quoted boundaries, separate logs, honest exit codes, and idempotent remote actions. If you eventually move to Ansible, Salt, or another system, these habits still matter, because those tools are also fighting quoting, state, and failure boundaries. For a 5-minute lab, use localhost or a VM you administer. Create an SSH config alias for it, or use localhost if your test account can SSH to itself. Write safe-ssh-demo.sh. Put strict mode at the top. Make a logs directory. Set one variable with a space in it. Escape it with printf %q, and pass it as a positional argument to remote bash. In the remote block, Create a directory under your home directory and print the received value. Run it twice. The second run should not damage anything, and the host log should tell a clear story. 3 beats to keep. First, strict mode belongs at the top of the local driver script and inside the remote bash block, but still check important results explicitly. Second, quote the heredoc delimiter so remote variables stay remote, and use printf %q when local values must cross into a remote shell command. Third, log per host and make every change idempotent, so a rerun is a repair tool, not a second incident. Tomorrow we keep building SSH from zero to expert, with another administration and defense topic. Also, watch for the daily ranked CVE brief on this channel.